Welcome, everyone. I'm Rosemary Bartlett with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's event, Performance-Based Compliance Documentation for ASHRAE 90.1, Section 11, and Appendix G. Our speakers today are Maria Cartman and Christina LaPearl of Cartman Consulting. Welcome to our speakers, and welcome to all of you. Maria, take it away.
So good morning, everyone, or good day, depending on where you are. So here is our agenda for today. It's a 2-hour training. We're going to start with overview of the general reporting requirements of 90.1. Then I'm going to pass it on to Christina, and she will talk about general layout of the compliance form. And then she'll go over the key input areas. She'll demonstrate instructions, dashboard, tabs where contact information and general information about the project is entered, such as project location, building type, and so forth. Tab where you enter different energy types used in the project. And then she'll go over some of the key data input tabs where you would enter information about lighting systems, envelope, and airside HVAC. And then towards the end, we'll demonstrate how simulation results are captured in the compliance form, and how compliance calculations are performed, and also we'll talk about submittal checklist that helps both modeler and reviewer to make sure that all necessary documentation is submitted. So as Rose has mentioned throughout this training, please type your questions into the chat, and then at the end we reserve 20 minutes to answer your questions. So the training format includes PowerPoint presentation. So again, as Rose mentioned, the slides are available at PNNL or at DOE website. We will also have throughout the training demonstrations on how to fill out the compliance form. So for each building system, for each type of input, we'll discuss what kind of information is available for you on the design documents, what are the related reporting requirements of 90.1 Section 11 Appendix G, and then there will be demonstration showing how to capture this information in the compliance form. So compliance form covers both Section 11 and Appendix G, but we only have 2 hours today to talk about it, so we will focus on 90.1 Appendix G documentation, but really documentation for Section 11 is very similar to that. So this diagram is taken from Standard 90.1. It's shown at the top of Section 4 of the standard, and it shows at a glance different requirements that projects have to meet in order to document compliance with 90.1, and different compliance options available within 90.1. Some of you may be familiar with ComCheck. So ComCheck is a tool that is developed and maintained with funding from Department of Energy. So ComCheck is used to document compliance with prescriptive requirements of 90.1. So up until now, there was no standardized reporting format to document that met reporting requirements of Section 11 and Appendix G. So different jurisdictions, above code programs that adopted this modeling protocol had to put together their own forms. So now this form that we will be talking about today was developed again with funding from DOE and PNNL. So the form meets requirements of Section 11 and Appendix G, and this form is the focus of today's training. So just a quick reminder of the general concept of performance-based compliance with 90.1. Two models have to be developed. The first model is the model of the proposed design that, generally speaking, reflects building systems and components that are specified. The second model is model of a virtual building, and the performance of this virtual building serves as a point of reference for evaluating performance of the proposed design. So the relative energy consumption of these two models determined whether the project complies with code, or these models can also be used to determine the margin of improvement beyond code. So the rules of how these two models are developed differ between Section 11 and Appendix G, but this is the general concept that applies to both, that there are two models that are developed. So these models are developed using the same simulation tool, the same weather file, and the same utility rates. And there are multiple simulation programs that can be used to develop these two models, and the simulation tool requirements are included within Section 11 and Appendix G, so any software that meets these requirements can be used for modeling. So quick overview of the compliance form that we will be talking about today. So it supports 90.1 2016 and 2019 editions of Section 11 and Appendix G. So Christina will show you there is a list box within the form where you select the edition of the standard and whether it's Section 11 or Appendix G path. The form is posted at DOE Building Energy Codes program website. DOE intends to fund maintenance and development, first of all, fund maintenance of the compliance form, if there are any bugs that are reported, and also to add new features. And DOE also intends to fund customized versions of the compliance form, similar to how it funds development of state-specific versions of COMCHART, for example, when states modify 90.1 requirements based on state-specific amendments. So the compliance form is in Excel format. It helps establish the necessary modeling inputs. It has many built-in code lookups and calculators. So, for example, it helps determine what the baseline wall construction or baseline lighting should be for the given proposed design. So it simplifies modelers' work in terms of having to go back to 90.1 requirements to figure out what should be modeled. We worked with vendors of popular simulation tools to allow importing simulation results from standard output reports generated by these tools into the compliance form. So currently, Design Builder Energy Plus, eQuest Energy Plus, Train Trace, and Opus Studio are supported. And then the compliance form also automates compliance calculations, because especially with the new Appendix G, establishing compliance based on simulation results is no longer as straightforward as just comparing energy cost of the baseline proposed design. There is certain calculation that should be followed that is sometimes misinterpreted. So compliance form automates that. And there are a number of improvements that are already planned for the compliance form. So there will be new versions posted periodically on GE website. Some of the planned enhancements include adding quality control checks tab that will flag, that will facilitate submittal review and flag simulation inputs and outputs within the compliance form that appear to be inconsistent with 90.1 requirements. There are also plans to expand data import and data export capabilities of the compliance form. So as I mentioned, for now, just importing of the simulation results from certain modeling programs is supported. And then another planned enhancement is addition of reports, including compliance reports that may be printed on drawings, and also reports that will facilitate site inspections. For example, when a site inspector goes to the site, they don't necessarily want to see or interested in the parameters of the baseline model. At this point, only the configuration of the proposed design matters, and that's what needs to be inspected. So there are often questions and even debates concerning level of detail that must be captured in the compliance form. So this is prescribed in standard 90.1, so it's not up to us to decide what level of details is required. So I copied here on the slide the relevant sections of Appendix G and Section 11 that describe reporting requirements. And the takeaway is that these requirements are very extensive. And here are the key highlights of what needs to be reported following this section of 90.1. So first of all the features that differ between the baseline and proposed design must be identified. Aspects of the proposed design that improve over prescriptive requirements or less efficient than prescriptive requirements. And I highlighted prescriptive requirements in red here because with Appendix G, prescriptive requirements are not part of the baseline model, so they're not really affect the simulation. So even though they are typically not captured in the simulation tool, not affect simulation results, still this trade-offs between the proposed design and prescriptive requirements need to be reported. Another very important reporting requirement is demonstrating that proposed design meets mandatory requirements of 90.1. So again, this is not something that affects simulation, but it has to be demonstrated to code official. In addition, compliance form should include energy consumption by end use for the proposed design and the baseline. And end uses include heating, cooling, lighting, service water heating, fans, pumps, so key systems and components that consume energy in the building. And then also energy cost has to be reported for the proposed design relative to the baseline. And last but not least, submittal must include backup calculations demonstrating how the modeling inputs were generated based on design documents. So the current documentation process involves design team putting together project documentation, including drawings, specifications, then modeler performing supporting calculations based on this documentation to come up with simulation tool inputs. Then the modeler again enters the information into simulation tool, and lastly fills out the compliance documentation. So this is the current process. So the improvement that the new compliance form brings to the table is that it incorporates both the supporting calculations and reporting within one tool. So modeler fills out the compliance form with information from design documents to calculate the inputs that would be used for the model, then enters this information in the modeling tool, and then once simulations are completed, the simulation results from modeling tool can be imported back into the compliance form. Design documents includes drawings, specifications, and typically this information requires significant processing, before it can be entered into the compliance form. For example, for lighting, design documents include lighting plans that show different fixtures specified for each space, and also lighting schedules that describe wattage of each fixture. So this information has to be converted into lighting power density for input into simulation tool. So compliance, compliance form helps calculate simulation inputs for the proposed design model, such as in my example with calculating lighting power density based on fixture counts and fixture wattage. It populates simulation inputs for the baseline model, such as lighting power density that should be modeled for each space or HVAC zone in the baseline. And then it also auto-populates prescriptive requirements that apply to the proposed design, which is one of the reporting requirements of 90.1 Appendix G. So modeler then transfers information from the compliance form into simulation tool and performs the simulation. And once simulation is completed, the simulation results are imported back into the compliance form that also performs compliance calculations to determine whether the project passes or fails code. So this slide shows how compliance form is organized. So each gray box within compliance form rectangle corresponds to individual tab in the compliance form. Modeler and design team would fill out the information on individual tabs sequentially. So again, for greatest efficiency, the compliance form should be filled out before modeling is done, because it helps generate modeling inputs. Then the information is entered into building energy modeling tool, and some of their simulation results are then brought back into the compliance form. For example, based on 90.1 Appendix G rules, the baseline HVAC system efficiency depends on its capacity, and capacity is established by running baseline model. So that's why there is this arrow going from building simulation tool to the baseline or budget HVAC box. So once simulation is performed and capacity of each baseline system is determined, it would be entered into the appropriate tab of the compliance form. But you can see that mostly the import from building energy modeling tool is limited to simulation results, so which are brought into compliance form by copying just standard simulation reports coming out of the tool into the dedicated version, dedicated tab within the compliance form, and Christina will demonstrate to you how that's done. So at the training today, we're going to go over just several of the tabs, and even the tabs that we go through will just cover some of the functionality within these tabs. So we're going to go over contact information, general project information, energy sources, and then envelope, lighting, HVAC tab, and compliance calculations group of tabs. And with that, I'm going to pass it on to Christina.
Thank you, Maria, for that overview. Can you hear me?
Yeah, and we can see your screen.
Perfect, great. Hello, everyone. Thanks for joining us today. I'm just going to dive right in and get started with the general features and the layout of the compliance form. Two tabs, which are informative tabs, and they don't require inputs from the design documents or from model output reports. They're also tabs that they don't do any calculations of model inputs. The beige colored tabs, those are tabs for modeler and or design team inputs, and they generate baseline and proposed model inputs. Then we have our bright green tabs, and those are for importing model output reports and for doing some automated compliance calculations. And lastly, we have tabs with checklists. As of right now, the compliance form has a submittal checklist tab to make sure that you are meeting all of the reporting requirements of 90.1. And we'll go over that tab in more detail later on in the training. Okay, so the default setting for the compliance form is to not show the formula bar or the headings. So the headings are like the A, B, C, D, E, and the 1, 2, 3 that you usually see on the screen. And then you usually see that white band here, and that's the formula bar. So the default is not to show that. For some of you, that may drive you crazy. So I just wanted to show you an easy way of changing that. So you just have to click on the View tab and then check Formula Bar and Headings, and then you'll be able to see them as you see here. Okay, next, throughout the compliance form, there are help buttons, and the user can click on these to get further guidance with regard to filling out the compliance form. But some of these help buttons also provide information from 90.1 with regard to requirements. So this is here, circled is this blue question mark, and it's a button that you can press on, and then a dialog box will pop up with the help text. And when you click on the text, the scroll bar will become available, and you can scroll through the text. You can also copy. You can also select the text and then copy it. So if there's a link to a website or something like that, you can easily copy and then paste it into your browser. Okay, so each tab has the same setup. So at the top, there's a Return to Dashboard button, and you'll see what the dashboard is on the next slide. But that allows you to just instantaneously click this and return to the Dashboard tab. There's also an Adjust Column Widths and Row Heights button. And this allows the user to adjust the column widths and row heights on each tab. Every monitor is different, and text that we can see sometimes won't fit with other people's settings. So this allows you to adjust the rows and columns so that you can see all the text you've typed in or the default text. The compliance form itself, though, is password protected. And this button allows you to adjust the rows and columns while still maintaining the protected state of the particular worksheet. Each tab also has a table of contents, which shows you all of the tables and sections on that tab and allows you to easily jump to different tables and sections. And finally, under each section and table is a note field that you can include any applicable notes. Okay, so this is that dashboard tab that I just mentioned. And the dashboard allows easy navigation to all of the different tabs in the compliance form. So what you see here in blue are all the different tabs in the compliance form. And when you click on the hyperlinks, it takes you straight to those tabs. So by clicking on the return to dashboard on the individual tabs, you can come to the dashboard instantaneously and then move on to another tab. So this means you don't have to scroll through a large amount of tabs, going, oh, where's that tab at? So it makes it just easier to use. The next aspect of this dashboard tab is that it has this compliance summary where you can see the energy modeling outcome at a glance. So that is based on any modeling output data that has been entered into the compliance form. So in this particular example, we have not yet entered data, so it's in progress. You can also see the compliance path at a glance. So this example is Appendix G, and it's the submittal for an above code program. We also have these design professional sign-offs and modeler sign-offs, and basically those are impacted by what's been filled out here. So what's kind of new with the compliance form is that we're trying to bring the design team into the modeling process. And in doing so, members of the design team are assigned to individual tabs. And it's their responsibility to ensure that the information entered on the tabs is in alignment with the design document. So you can see here that Jonathan Avery has been assigned to a number of different tabs, and then the date is entered for when he has reviewed the tabs and signed off that they're consistent with the design documents. For the energy modeler, the modeler is signing off that the modeling inputs shown on the tab align what's actually been captured in the energy model. All right, so now we're going to move on to the compliance form demo. And we're going to start with the instructions tab. So the instructions tab provides general information about the compliance form and step-by-step instructions for how to use the compliance form. So if you're in doubt, you can return to the instructions tab and look at the step-by-step instructions. It also provides some productivity tips, including the one about being able to view the headings and the formula bar. And it has a color legend. There are a number of different colors used in the compliance form, and you can find out what they mean from the instructions tab. It also has abbreviations and acronyms that are used throughout the compliance form, and links to different reference documents that are used. So for an example, we reference ASHRAE Appendix G schedules within the compliance form. So if you don't have that, you can just come to the instructions tab and obtain the link for getting to that information. Okay, so you can see that the instructions tab is blue because it's an informative tab. The dashboard tab is also blue because it's also informative. So we've gone over all the aspects of the dashboard, but this is what it looks like when you're actually in the compliance form itself. Okay. All right, so next we have our contact information tab. And this tab is where you would enter project information, project contact information, and the energy modeler qualifications. The next tab is the general information tab. And before talking about this tab, I just want to demonstrate the returning to the dashboard feature. So if I click on this hyperlink, I'm right back at the dashboard. And then I can just pop to any other tab I want. So I'll go back to general information and talk about this tab. So this tab is where basic information regarding the energy model and project is entered. So details such as the climate zone, the simulation tool used, and the weather file name, etc., are entered here. So Maria mentioned that we have a drop-down within the compliance form for choosing whether it's an Appendix G or Section 11 project. So that's on this tab, and you can see that you can choose 2016 Appendix G or Section 11, and you can do the same for 2019 projects as well. You can also choose whether you're filling it out for an above code performance or minimum code compliance. There are different rules depending on whether you're doing performance-based modeling for above code performance or for minimum code compliance. For an example, there's no credit for Energy Star appliances in multifamily buildings if you're doing minimum code compliance. So that's just an example. We also have a drop down with the list of popular simulation tools. And when you select your simulation tool, if it's a supported tool, the corresponding tab will become visible, and you can copy and paste output reports onto that tab. So today our example is eQuest. And then we have a section for capturing the different building areas in the project, and a section for describing if there are any renovations or yet to be designed systems and components, because 90.1 has specific rules how to treat these different components when you're modeling them. And then finally, in the basic overview section, we have our energy sources tab. And this is where all of the purchased energy sources, all of the relevant applicable to the project energy sources are entered. And we have drop downs for choosing the energy type and units. The person inputting the data also chooses the utility rate type. And there's a number of options to choose from. And there'll be throughout the compliance form, there are some flags to let you know that because you've selected a particular item, that you need to submit documentation. So in this example, because I've selected fixed rates per unit of consumption, I need to include some supporting documentation in my submittal for modeling those rates. And we have that submittal checklist tab that I mentioned, and that is dynamic. And when you select a particular option that triggers a need for documentation, that row will unhide on that checklist, so you can make sure that you submit all of the proper documentation. We also have other metrics in this table, and these are applicable only for jurisdictions that use alternative metrics for determining compliance, and they're optional. So source to site ratio and greenhouse gas emission factors are optional inputs on this tab. So when you select your energy types and your utility rate types, other tabs will show themselves as applicable to fill out the details of the particular rate structure that you're modeling. Okay. All right, so that concludes the basic structure section of the presentation. Next, we are going to move on to lighting. And we're going to touch on briefly the types, the tabs highlighted on the screen now. And generally speaking, as we cover these sections that involve modeler inputs and the automated calculation of baseline and proposed model inputs, it's structured where we're going to talk about the available information on the design drawings and in the specs. We're going to talk about the required simulation tool inputs, the applicable reporting requirements, and then we're going to go through an example of how to fill out the compliance form. So with lighting, we have the, as Maria talked about earlier, actually, we have our lighting plans, our lighting schedules, and our lighting specifications as part of the design documents. And you can't just take that information and put it into the BEM tool. It needs to be processed so that it can be input into the model. So as you can see here, in the model, you'll need to put in wattages per square foot or total wattages for each HVAC zone. And for the proposed design, you'll need to model schedule adjustments. So this is just to illustrate that there are intermediary calculations that need to be performed in order to transfer from here into the building energy modeling tool. And with lighting, the design documents provide schedules, so fixture schedules, with wattages for each of those fixtures that are typically based on the specified bulb and ballast. The design documents also have lighting plans, which show you the fixtures and specified controls in each space. And then if they're not on the design drawings, the specs can and often do clarify the actual lighting control sequences. Okay, so that information is in the design documents. However, the BEM tool, you need to calculate lighting wattages and schedule adjustment credits in the proposed design model for each HVAC zone. So that's one difference. The design documents, it's by space, but in the BEM tool, you're typically inputting the information by HVAC zone. Also, in the BEM tool, it's a requirement of 90.1 that you enter the wattage based on the fixture's maximum rated wattage. And this is often not on the design drawings, so it's something that as a modeler you need to check. And the baseline design model, you also need to determine the lighting wattages and schedules for each HVAC zone, which is going to be comprised typically of multiple spaces and often multiple space types. So you need to calculate that based on the tables and instructions in 90.1. Okay, what are the applicable reporting requirements for lighting? So Maria went over earlier the key documentation requirements in 90.1. And we've got requirements A, C, and E up on the screen. And they just basically boil down to you need to show differences, key energy efficiency differences between the baseline and proposed. You need to identify aspects of the proposed design that are less stringent or that are more efficient than prescriptive provisions of 90.1. And so for lighting, this corresponds to needing to show both the proposed baseline and prescriptive lighting allowances. So proposed lighting power, baseline lighting power, and the prescriptive lighting power allowance. So these need to be readily available for a reviewer to compare in order to meet the requirements for A, C, and E. And note, text in blue is not an actual simulation input. So the compliance form is there to help auto-populate these values to make the review process and the QC process easier. Next are backup calculations and material to support data inputs. So in the context of lighting, you're going to need to show a reviewer for the proposed design the fixture counts, wattages in each HVAC zone, and how the lighting power densities were calculated, and how the schedule credits were calculated based on the controls specified in the design documents. And for the baseline, you need to show how the modeled lighting power densities were determined based on the areas and space types within each HVAC zone. And lastly, the other applicable reporting requirements, well, they're all applicable, but the other one that we want to talk about today for lighting is the reporting requirement that you need to show that you're meeting all of the mandatory requirements of 90.1. And in the case of lighting, you need to show that you are meeting the lighting control requirements of the standard. And these are entered into the compliance form, which documents for the reviewer and authority having jurisdiction that you're meeting those mandatory lighting requirements. All right, here's our lighting example. Okay, so prior to entering lighting information into the compliance form, the building geometry and thermal zoning needs to be created in the BEM tool so that you know the modeled HVAC zone name associated with each space in the drawings. So that's the first step with lighting, is you want to know the HVAC zone associated with each space in the drawings. So here's an example. I'm showing you an excerpt from a set of design drawings that shows 2 spaces. So we have Project Storage 101G, and we have Metal Shop 101F. So we've got 2 spaces, and then this boundary here in red represents the boundary of the HVAC, of an HVAC zone. So we've got 2 spaces, 2 space types, 1 HVAC zone. And here in this graphic, you can see this HVAC zone in the model and its corresponding name. So we need to figure out the lighting power density and controls for each of these spaces, and then calculate the lighting power density for this entire zone. And we need to do that for the baseline and the proposed. Okay, so I'm gonna show you how that's done when we get to the compliance form, but I just want to zoom in and focus on one of the spaces. I'd like to focus on establishing the lighting count for project storage and the controls. And then we'll see how it's been entered in the compliance form. Okay, so here we have our project storage space, and as you can see, there are 6 V1 fixtures. So we get that from the lighting plans, but then we need to figure out, okay, what is a V1 fixture? So we look at the lighting schedules, and that gives us the make and model number, and it gives us a preliminary wattage. We then we want to check based on the model number that is actually the maximum fixture wattage, and that it includes all components contributing to power consumption. So we looked at this particular fixture, and we were able to confirm that the input wattage is actually 43.2 watts. So that is the wattage that we will model in the proposed design. So for our lighting counts, we have 6 B1 fixtures. They're each 43.2 watts, and our space is 471 square feet. Okay, So next we have to figure out what kind of lighting controls we have in this space. So you can see from the drawings that there's a symbol here that has a VC with an S, and then it's attached to these OCs. So we see we have that, and then we look at the symbols to figure out what these mean. And so we can see that the VCS is a vacancy sensor control switch, and that there's 2 occupancy sensors attached to it. Well, that still doesn't really tell me exactly the sequence, so I went to the project specs, and that tells me that the vacancy sensor is such that the lights are manually turned on, and that sensors turn the lights off when the room is unoccupied with a time delay. So basically, the lights in this space are all manually turned on. And then once they're manually turned on, the occupancy sensor sense occupancy in the space. Once there's been an absence of occupancy for a specified amount of time, it automatically turns all of the lights off. Okay, so we know what controls we have in our space, but now we need to define what controls we have based on how controls are captured and defined in 90.1. So in the compliance form, you enter the controls associated with each space based on the way they're classified in 90.1. So what you can see here on the screen are the control requirements for this particular space, which is a storage room between 50 and 1,000 square feet. Okay, so we can see that local controls are required. We can see that either restricted to manual on or restricted to partial automatic on, either one of these is required. So that's what the add one means. It means you've got to have either one of these. Okay. So next, daylighting, side lighting, daylighting controls, and top lighting, daylighting controls are required. Now, these are not applicable because this is an interior space, and there's no top or side lighting. And then we can see that automatic full off is required. Okay. So the question is, which of these controls do we have in our space? Well, we definitely have local controls because we have our local switch that controls all those fixtures. We know that we have restricted to manual on because we read in our specs that that's how that vacancy sensor works. An occupant enters the space and manually turns on all the light. This partial automatic on becomes NA because we've met one of these 2 requirements. The daylighting is NA as discussed. And then we've met the automatic full off because we read in our specs that after a set amount of time, all of the lighting in the space is turned off automatically. All right, so let's go to our to the compliance form and talk about how this information is entered into the compliance form itself. So we start on the lighting space types tab. And we start with table 2. So just let me back up a little bit. So for lighting, we've got, for interior lighting, we have 3 tabs. We have the lighting space types tab, we have interior lighting counts, and we have interior lighting model inputs. So as we go through each of them, you'll see how the features and how each of them works together. So whenever we're filling out lighting, we start with the lighting space types tab. And table 2 is where you define all of the different space types in the project. And the reason for this table is to eliminate excessively long list boxes when you're entering the fixtures associated with each space in the building, because I'm sure some of you are aware there are a lot of different space types in 90.1, and scrolling through long list boxes hurts the efficiency of filling out the form. So we predefine our space types, In our example here, we're just getting started, so we only have 2 space types. We've got the storage room and the workshop, and I've pre-filled this out. Then we've got our table 3. So table 3 is where you copy and paste the HVAC zone names from the simulation tool into the compliance form. And this makes it such that you can easily assign each space to an HVAC zone in your model. And it helps prevent typos is one thing, so that the compliance form can calculate the lighting power densities for each HVAC zone. So I've pre-populated this based on the geometry I created in my model. You can also enter these by hand. You don't have to copy and paste, although it's probably easier to copy and paste. So after I've filled these out completely, and normally you'd fill out all of your space types, but you don't have to. You can go back and forth. I go to the interior lighting counts tab. So the general tab layout is such that the fixtures are defined at the close to the top of the tab here. So as you can see, I've defined, predefined the fixtures that were in that workshop space that we did not zone into, but I've filled out the compliance form for that space previously. But I've defined also my B1 fixture that we saw was in our storage space. So I've captured that here. Then in this section, you enter the number of fixtures for each space in the design drawings. Okay? And then controls are entered over here, but we'll get to that shortly. There are a number of productivity features to help navigate this tab. The first one is that you can freeze pane by pressing Control-Shift-M. So this freezes the top row, and it freezes at the space type so that you can scroll across and still see them, and scroll down and still see the headings. So that definitely helps with productivity on this tab. You can also mark rows. So if you double click on a row, you can mark it in this orangey color. And that's useful because often you maybe have a question about a particular space, and you want to revisit it later. So it's nice that you can mark rows that are incomplete or you want to revisit. And just double click again to turn that off. We also have the filter feature. So right now I have it turned on. I'm going to turn off the freeze pane. So I have it turned so that you press this button to turn on and off. Right now I have it turned on. And basically you see these arrows here. This allows you to sort the rows and columns based on different column headings. So you could filter this so that you only show workshops, or you could filter it by area. These different column aspects you can filter it by. I'm going to turn filter off, so you just press it and now it's off. Okay, so with our example, I've pre-filled it out, and so you can see I have the space names here, and then I've selected the name of the HVAC zone that we saw on that slide, and they both have the same HVAC zone name because they're both spaces are part of the same HVAC zone. You'll see throughout the compliance form, you need to indicate where in the plans or specs that you got this information, and this is there to help you, if you're a modeler or a member of the design team, keep track of where you got particular information. And it's also there for reviewers to be able to check against the design drawings. You select your space type, you enter your area, and then you capture the number of fixtures associated with each space. And you can assign multiple fixture types to each space. So based on our example, and let me freeze panes. Based on our example, our storage room space has 6 B1 fixtures, so we've captured it there. So as you can see, moving across, if there's a particular area of a space where lighting's not yet specified, you would enter that here. This column just does with some special rules of 90.1 regarding retail. And as you can see here, the proposed design, baseline, and prescriptive LPDs auto-populate based on the entries. And over here, I enter my controls. So basically, I just enter whether or not a particular control is specified in the design. So in the case of our storage room, daylighting was all NA. All of the wattage was controlled, so I entered the total wattage of the space. Manual on was a yes. Remember, our controls were manual on. Partial automatic on was a no, and so forth. So you just select yes or no as applicable, and the compliance form will automatically calculate the credits to be applied to the proposed design schedules based on Appendix G. And you can see to the right as well, the mandatory requirements auto-populate for reference. And another feature is that these cells will show in red to let you know which items are required. And as you say yes, the red disappears. Okay, so that's our lighting counts tab. And lastly is our interior lighting model inputs tab, which basically quantifies the lighting power density and lighting wattages, both by space type in table 1 and also by HVAC zone. So you can see here, we entered so far the space is associated with one HVAC zone, and we have our lighting wattage and lighting power densities calculated for the proposed baseline, and then the prescriptive also populates for reference for that HVAC zone, so we can directly input that into the model. I also want to show you that there's some functionality in which if the proposed lighting power density is higher than the prescriptive requirement, the cell will outline in red to indicate that it is less stringent than the prescriptive requirements of the standard, and it highlights the border highlights in green if it's better than the prescriptive requirement of the standard. All right, so that concludes our lighting compliance form demonstration. Back to the PowerPoint. All right, so to conclude lighting, I just want to discuss some common lighting mistakes. The first is sometimes as a shortcut, modelers will choose the dominant space type associated with a modeled HVAC zone rather than using all of the areas of the different space types to determine the baseline lighting power density. And this is automated in the compliance form, so that should eliminate this issue or reduce it. The next is a failure to model proposed design controls, especially daylighting. We often see this, us ourselves, we're reviewers and also modelers. So we'll receive submissions where the lighting controls aren't filled out or are partially filled out. And sometimes this can be due to a lack of information in the design documents. At least now in the compliance form, it's very clear what information is needed so that a request can be made to the design team to get the information needed to really determine whether you're meeting the mandatory requirements. The next is a lack of accounting for areas where lighting is unspecified or where the design intent is for hardwired lighting to be supplemented with receptacle lighting. So that last part, an example would be like in a hotel, maybe the bathroom has hardwired fixtures and the corridor when you enter the room, but the design intent is for there to be table lamps So that's receptacle lighting. And so this needs to be accounted for. And so the compliance form automates this. As I showed you briefly, there's that column for entering areas where lighting is unspecified. And lastly, not modeling the maximum fixture wattage, and also failure to include all of the components of the lighting fixture. So like you need to include the lamps, the ballasts, drivers, transformers, all of those need to be captured. So a prime example actually with fixtures is often a fixture may be rated at 60 watts. Maybe because it's a fixture that, you know, an older fixture model that where, you know, people were using the 60 watt incandescent lamps frequently. And so the fixture is rated at 60 watts, but the design is for, you know, 8 watt LEDs. Well, you'd have to model the 60 watt fixture, not the 8 watt LED. So that's a common mistake. All right, so that concludes lighting. Next, we'll move on to the building envelope section of the training. And we'll briefly touch on the 3 tabs you see highlighted on the screen. And primarily, you'll see these tabs once we get to the actual example. But first, we're going to start just by discussing the information and the relevant information in the design drawings for building envelope and the BEM tool inputs. So in the design drawings, we have our construction assembly schedules. So the layer by layer assembly schedules. We've got elevations that show us build areas, window placements, areas of different wall types. And then we have our window and door schedules. The BEM tool, you need to model the thermal properties of the different constructions. You also need to model the window and door thermal properties. And you need to capture all those modeled area and door and window locations. So there definitely needs to be some organization and some processing of this information in the design documents. So specifically, you need to take the opaque assembly, the window and door schedules and their thermal properties. So you need to, like for an example, you see, okay, we have R19 insulation in this particular wall assembly. We have these different layers. So you need to take that information and calculate the thermal properties that go into the model and account for framing effects using Appendix A. So that requires some processing to go from those schedules with all the layers to the actual modeled thermal properties, accounting for the effects of framing. Okay. You also need to take the window and door properties, sometimes shown on the drawings. So sometimes there's U values and solar heat gain coefficients shown on the design drawings. You need to obtain the NFRC ratings to ensure that those thermal properties in the design drawings include the window frame. Okay, so that takes some organization in order to do that. So in the design drawings, you have elevations showing the window and door and different types of wall locations and areas, and you need to capture that in the actual proposed design model. And in order to figure out the appropriate model inputs, you need to not only capture those areas, but understand the different opaque assembly and fenestration areas by orientation, building area type, and then also the space conditioning category. Because those are important in determining the prescriptive requirements and the baseline model inputs. So for the baseline, you need to take that information from the proposed design and from the design documents, and you need to determine the opaque assembly and fenestration thermal properties to model per the rules of 90.1. Same with the window to wall ratio to model in the baseline. For Appendix G, it's often not the same as the proposed design, and that needs to be determined using the rules of 90.1. So in terms of documentation, we've gone over the meaning of A, C, and E here, I think twice. So I'll skip that, but in order to meet the reporting requirements of 90.1 and show how the baseline and proposed compare, and to show where you are meeting or not meeting prescriptive requirements, the reviewer and the modeler needs to see the opaque assembly and fenestration thermal properties, including U, C, F, solar heat gain coefficients, visual transmittance, all those thermal properties we need to see, or the reviewers need to see, for the proposed design and the baseline design, see how they compare in order to meet these reporting requirements that you see on the left. The prescriptive requirements also need to be shown for comparison purposes as well. In terms of backup calculations, it needs to be shown how the UC and F values were determined using Appendix A, and also how were the window to wall ratios and areas determined, how were they calculated? And that's true for both the baseline and proposed models. And meeting the requirement of the mandatory provisions is not yet supported by the compliance form. All right, so here's our envelope example. So we've got an exterior wall and a roof assembly from a set of design drawings. And so we take a look at this and we pull the relevant information. So in the case of the exterior wall assembly, we note that we have, here we can see that we've got the vapor retarder, and then we've got additional layers, and then we've got an insulation layer, and we have R19 cavity insulation, and we can see these design drawings are nice and detailed, and that it tells us it's 16 inches on center, and there are 6-inch metal studs, so that's great. And then we've got another layer of gypsum sheathing, and then we've got a weather-resistant barrier, and then we've got 2 inches of mineral fiberboard insulation, so that's our continuous insulation, and this tells us that it's rated at R8.5, and then we've got our outside stucco. So basically, we've got R19 cavity insulation and R8.5 continuous exterior insulation, 6-inch metal studs, 16 inches on center. So we get that from the design drawings, and I'll show you what we do with it in a couple minutes after we discuss the roof assembly. So for the roof, we've got our roof membrane, then we've got R39 of continuous insulation, and sorry about that. Then we've got our air/vapor barrier, and then metal decking. We also have our reflectance and emittance values. So just to summarize the important information here, we've got R19 continuous insulation. This is entirely above deck, as we can see here, with a reflectance of 0.55 and an emittance of 0.75. So the point of me showing you this is we're going to discuss how this is entered in the compliance form and how the compliance form helps us determine thermal properties, and how the compliance form meets the reporting requirements that we discussed. So then we've got our envelope elevations. which help us determine the fenestration areas and opaque areas for the different wall types by orientation. And if you have different building area types and different space conditioning categories, you'll also need to break down the different wall areas in terms of those variables as well. In our example, we just have a building that it's just it's the same building area type throughout, so we don't need to break it into that detail, but we do need to capture the wall areas for each assembly type by orientation, and same for the different types of windows. So this set of drawings provided that information right on the drawings, and so we extract that to put it in the compliance form in order to calculate some of our model inputs and to meet reporting requirements. And just note, it really depends on modeler preference and also the level of detail in the design drawings. Sometimes it's easier to just take this information out of the simulation tool, but that depends on the particular scenario. All right, so let's look at the envelope tabs in the compliance form. Wrong direction. All right, so we're going to discuss the proposed envelope assemblies tab, envelope areas, and infiltration. So we start with the proposed envelope assemblies, and on this tab you define all types of constructions in the proposed design. So table 1 here is for entering information about opaque assemblies and doors. Okay, so then we have table 2, and as you can see at the top, there's only 2 tables. Excuse me. And then table 2, we enter our fenestration. So in our example here, I've pre-populated it with the different constructions in the proposed design. But in our up-close example in the PowerPoint, we discussed the roof construction, and then the only, this is a pretty simple building, the only exterior wall construction. So we've got our roof, which as we saw was insulation entirely above deck. And these classifications here, so you define your surface type, your construction type, these are all based on Appendix A, okay? And they're drop downs. So they're all drop downs. So I go across and I enter this information. I get to column J. I get to the cavity insulation column, and there was no cavity insulation for the roof. However, if you recall, we had our R19, and let's take a look, we had our R39 insulation. So we enter 39 here for the continuous insulation, and the Appendix A U value auto-populates for us. And this is Appendix A issues are a very common source of review comments when conducting reviews. So this is designed to eliminate some of those comments and streamline the process for modelers and members of the design team. So sometimes you have materials that are different from what was used in the Appendix A tables to determine the thermal properties of the construction. So here you would describe the materials in addition to what was used in the Appendix A tables, and you would enter your actually modeled U, C, or F factor. So the Appendix A table is a helper for you if your construction is the same as the constructions used for determining the thermal properties in the Appendix A tables, then it would be the same. If yours differs, you describe that here and then show your actual modeled value. Then there are some rules in the standard for treating uninsulated assemblies and modeling similar assemblies. So you answer some questions that are drop downs here. And if you answer yes, it'll prompt you through these other columns to describe the uninsulated assemblies, to describe the similar assemblies. And as always, there's a column for entering the plan or specification reference for the information that you've entered in the compliance form. And for our exterior above grade wall, same process. And I just want to show you there is a feature of the compliance form. If I delete this, you see how that turns red? Well, for crucial inputs, now, you know, all of the peach cells are important, but for inputs where it's like, this is not going to work if you don't input something, it'll for the most part, turn red. So that's why that turns red, and then I enter my value and it's back to peach. So I've got my steel frame wall, 16-inch center, 6-inch depth. We had our cavity insulation, our 8.5 continuous. So same as for the roof. It auto-populated the Appendix A value. Okay. So then, fenestration. We didn't look at this in detail in the PowerPoint, but you would enter your you would describe your fenestration in the design documents. These are all drop downs, also based on Appendix A options. You would include the thermal properties of each type of window or each type of fenestration, your plan and spec reference. You need to indicate how the fenestration U factors were determined, because you need to include the effects of framing, and typically that's through NFRC testing. So you indicate that here, and again, depending on what you choose, you have a prompt to submit the certification or label. For an example, if you're saying that you used NFRC testing for the manufactured fenestration assembly as your way to determine the U value, well, then you need to submit backup documentation. And again, this row will unhide in the submittal checklist to make sure you don't forget. Okay, so that is the proposed envelope assemblies tab. So now we have the building areas tab. And at the top here in table 1 is where you define your surfaces, your opaque surfaces, by building area type, orientation, space conditioning category, and whether the area is new, existing to remain, or existing to retrofit. And I've pre-entered this information just for the sake of time today. And this information came from the, in this case, it came from the elevations from the design drawings, as you can see here. So I took this information and I entered it into the compliance form. And as you can see, the baseline and prescriptive thermal properties auto-populate for model inputs in the case of baseline, and to meet reporting requirements in the case of prescriptive. And I just want to briefly just touch on the colors here. The peach cells require an input. The white cells auto-populate and are not editable. And these like beigey purple cells auto-populate, but they're editable. Okay, so same principle for table 2, except you enter the fenestration areas in the proposed design by those categories that we discussed. So I took these from the building elevations design drawings and entered them here. And again, the baseline and prescriptive thermal properties auto-populate. So then on this tab, you would press calculate window to wall ratios. And this would calculate, when you press this, which I already did, the window to wall ratios and the different areas that need to be modeled in terms of fenestration auto calculates for the baseline and proposed design. And as I discussed before, Appendix G has specific requirements about the baseline for modeling the window to wall ratio. So this example that we're looking at right now is a school, And according to Appendix G, it should be modeled with a 22% window to wall ratio. And based on the entries in tables 1 and 2 above, these have been auto-calculated for you so that you can model the correct baseline and proposed fenestration areas. Table 5 is designed so that reviewers and modelers can QC their work and look at output reports and check that everything it has been modeled as it should be. Table 6 is for capturing exterior and interior shading. So you basically check what's applicable in the proposed design, and how it should be modeled in the baseline auto-populates. And then lastly, we have our baseline orientation and rotation section, and you select whether the baseline/budget building performance was generated by simulating the building with its actual orientation, and again, after rotating it by 90, 180, and 270 degrees, and then averaging the results. So you basically check whether you did that, or if there are a few exceptions in the standard where you don't have to do that, so you would click the radio button to indicate that there's an applicable exception, and then this field would become available down here where you would explain how that exception is applicable. It's understood. In that, baseline air leakage is prescribed at a pressure differential of 75 pascals, and it's normalized per unit area of the envelope pressure boundary. But actually, most simulation tools require entering infiltration at normal pressure conditions. So this Appendix G value at 75 pascals needs to be converted to normal pressure conditions, and this calculation is automated here. And a number of infiltration modeling methods are available for selection in this dropdown. So you could select to model the leakage per gross floor area, per exterior wall area, and when you select different ones, it'll update your actual model input for you here at normal pressure conditions. Okay, so that concludes our demonstration for building envelope of the compliance form. So basically, I just want to touch on some common mistakes for envelope. Typical mistake is modeling the center of glass U value as opposed to the NFRC assembly U value, which includes framing. So we see that a lot, and we try to help modelers avoid this by prompting you to indicate the method used to determine the model's U value. So that'll eliminate a lot of questions, because this comes up a lot in reviews. So a failure to model or count for in the model uninsulated slab edges that penetrate the wall plane on each floor of the building. So by having to enter each unique construction on that proposed envelope assembly tab, hopefully this will help eliminate that mistake, because you'll need to explicitly enter the unique assembly associated with that slab edge. Not using Appendix A to account for the effects of framing when determining proposed design opaque assembly thermal properties. So this is very, very common. So the hope is that since we've automated for most constructions this process of determining the Appendix A value, that this issue and the number of review iterations will be reduced. Another, modeling the same window to wall ratio in the baseline and proposed. So as discussed, the baseline needs to be determined based on the rules of Appendix G or Appendix G models, and this is automated in the compliance form. And lastly, I already discussed this, but modeling infiltration, so entering the value from Appendix G, which is at 75 pascals, into the simulation tool, when the simulation tool requires that input at a different conditions. So since we've automated that process, we're hoping again that that will reduce the number of review iterations. All right, so next we have HVAC, and we're going to touch on the two tabs shown there. Okay, so with HVAC, we have our design documents. Once again, we have mechanical equipment schedules, riser diagrams, we have HVAC plans, which include piping, ductwork, and so there's a lot of information in the design documents with regard to HVAC. And there's also a lot of then tool inputs that need to be made. You need to determine the appropriate system type based on your design documents. Your HVAC zoning. Then you need to determine what types of controls to model for each of these systems. Then the efficiencies and all the other parameters like fan power, pumping power, all of those items need to be determined from the design documents so that they can be input into the building energy modeling tool. So to be more specific, we get the HVAC capacities, efficiencies, different components. Are there CO2 sensors for demand controlled ventilation? What are the control sequences? How do the units operate? And we get make and model numbers from the equipment schedules. So we can determine zoning from ducting and piping plans. We can also determine heating and cooling capacities by HVAC zone from the ducting plans as well. And then all of that information needs to be organized and then input into the model. So for the proposed design, you need to zone your building. And then you need to figure out for each zone what equipment serves that zone, what's the capacity, what efficiency should I model, and for efficiency, you often need to remove fan power, so there's an intermediary calculation. Often you'll need to do a fan power calculation to convert the information on the design documents to kW per CFM. Depends on how you're modeling it, but that's typically a calculation that needs to be performed. And then all of the control sequences to input the controls and the control parameters. Baseline design, the HVAC zoning is the same as proposed, but you need to determine the efficiency, fan power, pumping power, and the control sequence. That needs to be figured out from Appendix G. And these items are automated in the compliance form to help with the organizing and figuring out those model inputs. In terms of reporting requirements for HVAC, you need to show the differences between the baseline and proposed for equipment types, the capacities, the efficiencies, the control sequences, lots of different items. You need to show whether you meet or exceed the prescriptive control requirements. For an example, does your design have economizers, things like that. In terms of backup calculations for the proposed design, depending on how you're modeling it, but typically you need to show how is fan power determined, how is pumping power determined. From the baseline, you need to show from Appendix G, how was the fan power determined for this particular project? How is the pumping power determined? The efficiency, the controls, all of these items. You need to provide backup calculations, and this is automated in the compliance form. And in terms of showing compliance with the mandatory provisions, the mandatory controls and the required minimum efficiencies will auto-populate. So this is our HVAC example. This is an excerpt from some design drawings. And I've highlighted the important inputs here in yellow. So these are 2 rooftop units. They each serve an office. These are interior offices, and they actually, based on the rules of Appendix G in the model, they were able to be combined into one thermal block, one thermal zone. So we've got our supply CFM, our minimum outside air CFM. We've got our motor, supply fan motor brake horsepowers. We've got our heating capacity. We can see this is a gas furnace unit. So we've got our heating capacity. Cooling, we've got our cooling capacity here. We can see that it's a DX unit from this information here. There's a condenser with fans. They've got entering air, leaving air temperatures. We also have our manufacturer and model here too. So if there was any doubt, you can always look that up. We've got our cooling part load and full load efficiencies here. And then we have our filter type, which can be important if you are claiming allowances. Well, if you're claiming allowances for pesticide. And always the notes always have some good information as well. We can see these are variable air volume. They have VFTs. We see the supply temperature controls, and then we can see that they have enthalpy controlled economizers with, and we can also see the high limit set point. So this is all the important information that we'll need to enter into the compliance form. So let's dive right into the compliance form for HVAC. All right, so on a high level for HVAC, we have the proposed HVAC tab, and then we have the baseline HVAC tab. If this was a Section 11 project, then you would, instead of baseline HVAC, you would have a budget HVAC tab. And the first thing I want to point out is just when you look at the baseline HVAC tab, there are many, many auto-populated values. And that's because the baseline tab automatically tells the modeler what the baseline model inputs are based on lookup tables from Appendix G that are integrated into this tool. You can see a lot of white and a lot of this tan color. And the reason the tan color, not tan color, beige color, beige purple color, and the reason you see that is sometimes there are exceptions that apply, so the user's allowed to override them. Okay, so that's the baseline tab. So there's many auto-populated. See, look at all the controls auto-populated. Right, so let's look at our let's look at the proposed tab, which is mostly going to be this peach color, and that's because you're entering your unique design. So the compliance form can't know what your unique design is. There's a productivity tip for this tab. Each of the tables, if they're wide, have a freeze panes button, so you can click that, and it will freeze the top row and the system name so that you can easily navigate the table. Click it again, and then it turns it off. So I've pre-entered the rooftop units, and as I said, they're modeled as one thermal block based on the rules of Appendix G. I entered my drawing plans and specifications reference for that unit. So just from a high level, let me step back here. On each HVAC tab, we've got a table of contents, and we've got tables for describing the airside HVAC system type, capacity, and efficiency. We've got tables that deal with system fan power and efficiency. We've got a table for capturing any pressure drop, fan power pressure drop adjustments. That's why I brought up that filter. We've got a table that captures controls, economizers, demand controlled ventilation, energy recovery. We've got a table that captures the different aspects of loops. So loops, hot water loops, condenser water loops, they're described in one table. A table to describe cooling plants and heat rejection equipment, and then a table to describe heating plants. The information about these items are entered in their respective tables. So I'm going to briefly touch on each table with our example. So we've entered the rooftop units in table 1. So many of these are drop downs. So for example, equipment type, these units are a central furnace. There's a drop down for selecting the equipment type. We entered the capacities in this section, describe some information about perimeter radiation, reheat. Same with cooling. Now cooling, equipment type, drop down. Then we enter the capacity, and we enter our efficiencies, including our modeled efficiency, which fan power had to be removed. And then our minimum allowed efficiencies per the standard auto-populate here. And it might be difficult to see through the screen share, but because our efficiencies are better or equivalent with the minimum allowed efficiencies in section 6, we have a green, they're highlighted in green here. We also need to describe the performance curves used in our modeling, and we have a drop down here for selecting that. So each table, we just enter the details of our proposed design. Under each table is a summary table that summarizes the information entered in the table above. On the baseline design tab, these summary tables compare the proposed and baseline design, which makes QC and review a lot easier. So then we've captured our fan power based on that brake horsepower that we discussed here, the fan flow controls. So then, you know, if we had other fans, we would capture them in table 2. We need to type our applicable drawing or spec where this information is coming from. So we entered that here. And then any relevant pressure drop adjustments, controls, we've captured those here. And no other tables were relevant. So if a table isn't relevant, like for an example I showed you at the top, there are heating plant and loop and cooling plant tables, but they're not applicable to this unit. This is DX and it's a furnace. So we don't need to fill those out, so they don't show themselves. And with the controls, so whether it's required, auto-populates. And you can override this and then indicate which exception is applicable for transparency. So that's HVAC in a nutshell. So let's go back to our PowerPoint now and talk about some common mistakes. So some common HVAC mistakes is modeling the incorrect baseline system due to the incorrect application of G 3.1.1.1A through H. And we have narrowed the selections a little bit based on upstream inputs in the compliance form for the baseline type to try and help with this particular issue that comes up. So we often see a failure to remove fan power from the baseline and proposed efficiencies where it's applicable. The baseline automates this process. The model input auto population automates this. Modeling the same controls on the baseline and the proposed instead of following the rules of Appendix G. This is automated in the compliance form to reduce this issue. And then finally, modeling different outside air CFM rates in the baseline and proposed model when there are no exceptions. So there are limited exceptions where this is okay. But we see this a lot when none are applicable. And you need to indicate how you need to provide information about this in the compliance form. So you need to select whether there's a reason for modeling different ones. And this will help reduce this issue and error. All right, so we want to leave time for questions. So We only have a few more slides left, but we're going to cover the simulation outputs and compliance calculations sections. And the relevant documentation here, as Maria discussed, is you need to provide a summary showing energy cost savings with respect to the proposed. So the compliance form, this is met in that it shows the baseline and proposed design costs by end use for many end uses. Another requirement that Maria talked about is that you need to provide input and output reports that show a breakdown of energy use by at least the following components, and Maria mentioned these: lights, surface water heating, space cooling, and these are all captured in the compliance form. As Maria said, modelers can paste the standard reports into the compliance form, and these end uses, the energy consumption will automatically be calculated. Also, part of I is showing the unmet load hours for the baseline and proposed models, and this is also automated for the tools discussed earlier in the compliance form. So the supported tools are listed here, and as Maria said, we worked with the vendors to develop tabs where the standard reports can be copied and pasted. And once these reports are copied and pasted, then on the compliance calculations tab, the compliance outcome is automatically calculated. And like Maria said, some of the calculations can be a little complex for Appendix G. So this process is automated, and the calculation also includes the caps, if applicable, for on-site renewables or exceptional calculations. And there are areas in the compliance form for entering that information, but that's outside the scope of today's training. All right, so I just want to show you these tabs. So for this example, it's a eQuest example. So I've pre-populated this tab. I just copy and pasted the result, the output in the PARMS file into this tab. You can see there are instructions telling me how to do this at the top. So I just copy and pasted that. And then I went to my compliance calcs tab, and I saw that the information I copied and pasted resulted in some auto-populated tables. So you have to press, depending on when you first click on this tab, you need to press these buttons for them to auto-populate. I already did that. So my unmet load hours populated. Then in table 2, which shows the energy consumption by end use, this also auto-populated. And you can make manual adjustments to this. So as you can see, it's that beigeish purple color. So auto-populated. But if you need to reclass something as unregulated or regulated or add end use, you can do that. And then you can select different columns on the results from eQuest tab to bring in the consumption associated with those columns. So we have, and all of these can be manually entered if needed. And then we have table 3, which is a summary of the costs, and it compares your modeled baseline and proposed design dollar per unit costs to show if there's any variation. And again, these can be overridden if needed, but these auto-populate based on the results from eQuest. The other tables are just summary tables until we get to our compliance calculation table, which is what I showed you in the PowerPoint presentation. So this shows us our compliance outcome for our submission. So those are the results from STEM tool and compliance calculation tabs. All right. So lastly, we've got our submittal checklist. All right, so we see that this huge, big, long list again. So these are all the documentation requirements in Appendix G. And they're not here for you to read each one, but just to show that they are significant. And the submittal checklist was created to ensure that each one of these, the design team and modeler is reminded about, and they can make sure that they include each one in the submission. So let me show you what this looks like. So this here is the submittal checklist. Note that this is just showing you as if someone had completed the compliance form. This one is obviously in progress, but I just wanted to show you an example of a completed one. So it lists the information that must be provided, and you can fill it. The color scheme here is that the peach colored cells are for the design team and modeler, and these blue cells are for the reviewer to make comments. And once the modeler or member of design team, make sure that they've included the item, they would turn this from no to yes. So green is good, you're ready to submit your package to the rating authority. So once the rating authority has reviewed it and they don't need any extra documentation or clarifications, they can mark it as resolved and it grays out. And you can kind of see the white text. All right. So some of the items on here: weather file used, explanation of error messages, diagram showing thermal blocks. So these are all included in the Appendix G requirements. All right, back to the PowerPoint. Okay, so that concludes the training, the organized training part. So now we would love to have any questions that may have come up.
Thanks, Christina. Thanks, and we have a good number of questions, so I can answer them one by one. So the first question, slide 7 states that the import can come from a range of BAM tool, but ISV was not mentioned. Are you saying that the spreadsheet only allows input from the named tools? So spreadsheet only allows importing information from the named tools, but modelers can also just type in results into the compliance tab, and we have been working with the software vendors to incorporate data exchange, and I hope we will be able to support ISV. And then another popular tool that is not yet supported is carrier hourly analysis tool. So we hope that in the next versions, these tools will be included. Next question, will GBCI accept this compliance form in place of the minimum energy performance calculator? So we have been talking with GBCI about that, and their current plan is to post the link. The current plan is to allow this compliance form as an alternative documentation method, and post the link to this compliance form at LEED online website. So I mentioned to you at the beginning that for some jurisdictions in the above code program, the form can be customized. So there may be some customization that will be made to the compliance form to tailor it to LEED specific requirements. But again, the bottom line is that yes, as it stands now, the GBCI does plan to accept this is an alternative reporting format for minimum energy performance. Next question, how is the modeling outcome show cost, performance, and usage? So this is all shown on the compliance calculations tab, and Christina demonstrated it to you that the compliance form uses conversion factors that modelers specified, conversion factors from site to source energy, from site energy to emissions, and display energy use of the baseline and proposed design in this alternative formats. So next question, what happens if you choose other from the simulation software? So if you choose other, then modelers can just manually enter simulation results into the compliance form. So you can use any tool that meets 90.1 requirements to perform the analysis. You just need to manually type in numbers, and again, we'll be happy to work with the vendors of other tools to automate this data exchange between the tool and the compliance form. Next question, can the baseline design parameters be changed or are they set? So certain baseline parameters can be overwritten, and Christina demonstrated one such area where the economizer requirement applies was selected by default as either yes or no, but then modeler could overwrite it and cite exception that applies. So in some cases, compliance form would allow you to do that. In other cases, the baseline value will be non-editable. You know, for example, baseline lighting power density would be non-editable. But in most cases, there is a column to the right of the table, which allows you to allows modeler to include notes. And perhaps if you need to override some of the default baseline value, that would be a good place to clarify why it was modeled differently compared to what's included in the compliance form. So the next question relates to the supported versions, to the versions of 90.1 that the compliance form supports. And the question is that most of the states are using 90.1 2013 or older. So how do we handle that? So the form supports 90.1 2016 and 2019. And Mike Rosenberg actually looked it up during the presentation, and believe, Mike, and I don't see the exact numbers, but about, okay, got it. So 11 states use 90.1 2016 and more considering adopting it. In other 16 states are either the process of adopting 2016 or considering it. So probably the first one was 2019. So again, good number of states are either already using 2016 or 2019 or considering it. So the form would address needs of the states. Mike, you want to add something?
I don't know if you can hear me or not, can you?
I can hear you now, but not before.
Right. So, yeah, about 11 states are on 2016 or the equivalent IECC that allows compliance with 2016 right now. And an additional 16 states are in the process of adopting it, or their processes are considering adopting it. So in the short term, there'll be about half the states we anticipate will be on 90.1 2016, with one state adopting 2019 in several months.
Great, thanks, Mike. So another question regarding lighting: if the fixture is rated up to 60 watt, but you inspect and see an 80 watt lamp installed, would you make an 8 watt lamp? Would you take an 8 watt lamp since it was installed, or still use the maximum rated of the fixture? So 90.1 requires you to model the maximum rated for the fixture, but some adopters allow you to model what's installed. For example, EPA Energy Star multifamily high-rise program that is based on 90.1 Appendix G allows to use installed lighting wattage. So I recommend checking the rules of the program for which you are doing the modeling, either State Energy Code or the above code program, and see if they have any rules that deviate from 90.1. So there were a number of questions about ASHRAE endorsement of this compliance form. And in general, ASHRAE doesn't endorse any software. It doesn't have any required compliance forms. So compliance forms are included in 90.1 users manual, but even these forms are there for just reference, so they are not mandatory. So this form was developed with direct engagement of 90.1 committee. So committee is aware of that, and we have 3 members of 90.1 ECB committee who were directly involved with developing of this compliance form. All right. There are several questions related to 90.1 requirements that are not specifically related to the compliance form, but sounds like we have a little time, so I'll try to answer some of them. If you use a high performance infiltration barrier, can the energy savings be considered? Also, what is the basis of the spreadsheet derived infiltration rates? So the rate, infiltration rate included in the spreadsheet is based on requirements in 90.1 Appendix G and also Section 11 that prescribes the default infiltration rate that must be modeled for the baseline proposed design. You can model lower infiltration rate for the proposed design if air leakage is tested. So then you can model this tested rate for the proposed design. So, but just the fact that there is an infiltration barrier installed wouldn't allow you to claim this credit. The next question, is there a place in the tool or accompanying documentation where common mistakes are listed so the designer can quickly scan through them as a final checklist? So one of the updates that is being planned to the compliance form is addition of quality control tab, and it will include number of checks to help organize the review process, and we will address this common mistakes within this quality control tab. There will also be a companion submittal review manual that will be a PDF document, and it will also elaborate on best review practices and common mistakes. And we have good number of other questions, and I don't mind staying on longer. So that there's one question from code official about his jurisdiction requiring com check. He writes, this tool appears to be valuable for consistent plan reviews, but our jurisdiction requires a com check report even if taking a performance compliance option. So we hope that perhaps jurisdictions like this one will consider using the compliance form is the only reporting requirement, in other words, not asking modelers to also fill com check, because as I mentioned, this, and as Christina described, this compliance form is meant to fully meet reporting requirements of 90.1, for Section 11 Appendix G projects, and we are planning to add reports that will facilitate site inspections right to this compliance form. So another question about LEED, minimum energy performance calculator, and whether this can be used. So again, I would, if you intend to use this compliance form for LEED project, I would double check with GBCI first, but as of now, they do plan to allow it. Where is the compliance form acquired? So there is a link to the compliance form on the DOE website. And
Richard actually added that link, Maria, in the chat, so attendees can look at the chat window, and the link is there as well.
Okay. Yeah, thank you, Rose. And then I see some complimentary notes about the compliance form. Thank you for that, and we're all very excited about having this tool available. And you know, I'm sure once people start using it, there will be bugs, and we will work to fix them and make productivity improvements, and hopefully it will simplify life for both modelers and submittal reviewers. But we really hope that it will see a lot of use, because that's the best way to improve the tool, to have people use it and comment on it. And you can submit comments on the tool to DOE code help desk, and I think there is a link for that right within the form, or you're also welcome to just email Mike, me, or Christina if you have questions.
That's great, Maria. Thanks very much, and thanks to Christina also for a great presentation. And we'd like to thank everybody for participating in today's webinar brought to you by the U.S. Department of Energy's Building Energy Codes program. Thanks to all.